Hello. We are live, everybody. Welcome, welcome. This is December the 9th, 2024. Today. Feeling good today, guys. Feeling good. Back at work. Today's Monday. It wasn't too shabby. We got some stuff done at work. Did what we needed to get done. Hope everyone's having a good day. Let's just let the Discord know that I am live. Cool. All right. Hope everyone is having a great day. Today we are going to dive into data structures and algorithms, Chapter 3 reinforcement problems today. Um, we are on 15. We're making good progress on the Chapter 3 problems here. So I think we're only going to get to 31, so we're almost halfway done with these. So maybe one or two more days on these problems, but I'm really eager to actually work on the small business manager today because we made a lot of good progress yesterday, and it kind of sparked a little fire, and I'm feeling, inspired to program and write that up. So hope everyone's having a good day. All right, let's go ahead and open up a new file for R315. Key.py. Okay, and let's go ahead and copy over this problem. Hey Jeremy, welcome back. You're like as consistent as I am here with coming in. Appreciate you stopping in. Welcome in. You are number one today. How are you doing so far? I saw that you were finishing up finals. You getting a little break here before the next semester or quarter? What kind of schedule are you on? I'm not gonna lie, I miss being in college a little bit. It was fun looking back. Just I think I took advantage of what it actually was, just learning and having fun. Just it didn't, but in hindsight, right? Show that f of n is O of g of n if and only if g of n is omega f of n. Okay, so omega uh, f of n, right, is going to result into this kind of function. So omega f of g of n equals omega f of n. Okay, so we have omega f of n. So g of n, let me just think here real quick. G of n is, f of n is, so f of n is less than or equal to some constant c, right, times g of n, right? And then we know, so this is f of n is O g of n. Lots of parentheses here, guys. Get confusing typing out. Yeah, no school until next semester sometime in January. Wow, nice. I keep forgetting that it's like midway through December already, man. Time just keeps flying. Like I still feel like we're in November. Like it's just nuts. That doesn't make sense. The days just keep counting on by. It feels like I'm just kind of watching them go by sometimes, It's kind of sad, but that's life, I guess. Life speeds up when you get older, as they say. Okay. Let's stay focused here. So g of n is omega f of n, right? Would look like something like this. Is greater than or equal to C of n, C of 2 times f of n, right? So if we know that g of n how can we show this exactly, right? So we know that f of g of n can equal this, and we have a g of n value here. We know f of n can equal this, and we have an f of n value here. Show that f of n, right? Whoops, is omega f. Dropping a little bit of bit rate here. Sorry, guys. What's going on? All right, I think we're okay. Sorry about that little bit of lag. Sometimes my internet just kind of drops some frames for some reason. Not sure why. I'm the only one using it. The only one paying for it. Okay. So we know that g of n is greater than or equal to this function at some instances. So we can plug g of n into here because it is greater than f of n at this point. So show that f of n is if and only if g of n omega is f of n. So let's plug in the first function, the bottom function, into the first function. So f of n is less than or equal to c1 times c times c underscore 2 times f of n. And so this would give us f of n is less than or equal to c1 So this is not what we wanted to do. We need to keep g of n. We need to prove that f of n is O of g of n. Okay, so this would give us, if we plugged in g of n into this function, either way we would get f of n is less than or equal to g of n. Right, like that. And so then if you did the opposite and plugged g of n or f of n in for g of n, it would do the same, have the same effect. Right? No. G of n. So this would show that g of n is greater than or equal to omega g of n. Now, I'm not sure exactly what this, depicts to us though. Like, what does this tell us? Like, that's the hard part. So, if f of n is O of g of n, we can write that as this, where f of n is less than or equal to some constant times g of n, right? If g of n is omega f of n, well, we know that g of n is greater than or equal to some constant times f of n, right? So in this first instance here, I plugged the g of n equation in for g of n, right? And we got f of n is O of f of n time, right? Is this omega or just O of g of n? We have an omega notation here, right? So I don't see how we could just not, factor that in. Let's see here. Before you begin, analyze my answer and coach me to the right one. Making fixes to understand where I went wrong. Okay, let's break down your response step by step to pinpoint where adjustments are needed and guide you toward the correct approach. Starting with definitions. You correctly begin with f of n is O of g of n, which implies that g f of n is less than or equal to some constant c times g of n, right? And g of n is omega f of n implies that g of n is greater than or equal to some constant c2 times f of n, right? This is a solid straight point since you're establishing two definitions correctly. A solid starting point, sorry. Combining definitions. You attempted to combine the two definitions. To combine them, you substituted g of n from the omega definition into the O definition. From this, you concluded that f of n is less than or equal to O of f of n. Symmetry for g of n. You mirrored the approach for g of n, concluding that, yes. Where issues arise. I think I'm already kind of identifying where I arise. I can't substitute this equation directly in. I need to refactor this, I think, for When you combine the f of n, the O of n equation, and the omega of n equation, you substituted g of n directly into the inequality. However, this step doesn't preserve the intended meaning of big O because big omega and O big omega because these are asymptotic bounds, not equalities. Specifically, the omega function does not imply g of n can simply be replaced with Instead, these bounds should be analyzed across n its limits. Circular conclusion. Your reasoning loops back to, which are true but tautological. They don't demonstrate the equivalence you're trying to prove. Okay, how to fix and proceed. To understand this equivalence, it's helpful to use the formal definitions and work towards showing that if one conditions hold, the other one must necessarily follow. Revisit the definitions. Okay, so let's go back here to our definitions. Come on, doing this. Okay. Restate the definitions. Okay. Okay, I am back. Okay, here we go. I'll just copy in my definitions here, and we'll move on. Now let's analyze these step by step to clarify and demonstrate the equivalence. Big O definition. If there exists c values greater than 0 and n naught such that for all values of n greater than 0, the n naught, if f of n is less than or equal to c, okay, this is the big O definition of big omega. We aim to show that these two definitions imply each other. Simply that, okay, so we're implying, this implies that, okay. Assume the f of n is less than or equal to c1 times some constant times g of n. To show that g of n is greater than or equal to some constant, we arrange f of n is less than or equal to g of n is greater than or equal to. Okay, so we need to refactor this like we were thinking before. So let's go ahead and refactor this down. So let's go like that, and then if you would essentially subtract c, no, you would by swapping the multiplication. Now I have to remember my inequality rules here. Oh boy. So I know you flip the sign for when you do something, but what did they do exactly? So this is, oh, so they just divided by f? No, they divided by g. No, they divided by c. Yeah, they divided by c, which flipped the sign. Okay. So they just took this whole side of the equation, right? And then they divided it by c1 to cancel out c over here. And then they took this side and made this divided by c1, right? And then what we got below it is f of n divided by c1 is greater than or equal to no. So the f of was on the other side. They divided by c. Oh, the equality did not flip by divided by c, actually. The equality stayed the same. Interesting. So the equality stayed in the same direction and favored towards g after this case, okay? So then that would go away, that go away, this goes away, right? So this is a refactor, the big O definition to resemble big omega, right? So now what we can do is this simply just states, now does it want us to plug in? Okay. Rearrange to this. Set C2 equal to 1 over C1. Thus, implication 2, g of n. So you do the same thing for the other side. F of n is O of g of n. Okay. Yeah, so we were on the right track with the plugin. It's just we had to refactor these statements to, reflect big omega notation or big O notation. The big, okay. So now we can simply come down here and substitute we can, what they do is they just say that they set C1 equal to are you setting C1 equal to 1 over C2 because they are constants and they don't essentially matter for time complex defs, or are they physically the same number where Hey General Talk, thanks so much for joining the stream. I appreciate you coming and leaving a message. That's a great question. Let's clarify why we set C1 equal to 1 over C2. We set C1 equal to 1 over C2 because we're constructing a relationship between the constants that satisfies the definition of O of G of n and omega f of n. The two constants C1 and C2 don't have to literally be the same number, but must satisfy the reciprocal relationship to make the bounds consistent. Constants in time complexity definitions. The exact values of C1 and C2 don't matter as long as they are finite and positive. What matters is that these constants exist to bound these growth rates. Why a reciprocal relationship? From the definitions, to ensure these inequalities hold simultaneously, we define C1 and C2 as reciprocals. So this, right, the big O notation implies big omega 1 over C. Okay, yeah, gotcha. This alignment ensures that f of n and f of g are appropriately bound relative to each other. Constants are not physically the same number. C1 and C2 are not literally the same, but are inverses of each other with the scope of these definitions. For example, C1 is 2, C2 is 1 over 2, and vice versa. Why does this work? In the context of time complexity, these reciprocal relationship ensures that the asymptotic growth f of n and g of n are correctly compared. If f of n is less than some constant times g of n, so the big O notation, there must exist a C2 such that g of n is greater than or equal to C2 times f of n, and setting C2 to 1 over C1 guarantees this. Final thoughts. The exact numerical values of C1 and C2 do matter as long as C1 and C2 are finite and positive constants, and the definitions hold true. Okay. You can set C1 equal to C2 in this case, right? So we'll refactor this and say, right, it's times 1 over C1, right? Like that. Oh, no, I gotta go like this, like that. Okay. So 1 over C1. I'm going to take this definition right here and bring this back here. So we'll say times 1 over C1, right? We'll copy this above as well. Never mind. Over C1, 1 over C1, 1 over C1. Ooh. General Talks, you did a haircut, looking good. Thank you, I appreciate it. Yeah, I cut my hair probably like last week or so. You know, it's getting long and it was just annoying me, so I chopped it off and we're starting over here. Thank you for the comment. All right. My dog's growling. Sky, stop growling. Okay, so we multiply by 1 over C1. Set 1 over C1. So because we have now inverted C1 as 1 over uh, 1 over C1 to fit the big omega definition, we can now say that C1 over C1 is equal to C2. So C1. Muna says, hey, wow, you gained like 30 subscribers in a day. Yeah, I know, it's crazy, right? I can't believe I woke up and we were at like 3:30 and I was like, oh my gosh. So insane growth. Thank you so much, guys, for tuning in and giving me support. It really helps me to get sit down after my long day at work and continue to use my brain rather than just watch The Office and veg out. Okay, so C2 is equal to 1 over C1. 1 divided by C1 is equal to C2. So then you can plug C2 directly into there. So this becomes this function, but f of n times C2, right? Sat, and then, yeah, we'll say satisfies the big omega, oh, yeah, definition, right? And then we'll say big O of f of n is equal to g of n, right? So now we need to, unfortunately, show this for the inverse now, for this portion. So we can do this really quickly, guys. Just bear with me. So we have g of n is greater than or equal to C1 times g of n. Then we have another comment. Let's just paste these down. We have another comment. And we say that g of n times 1 divided by this should be C2, and this should be f of n. Okay, 1 divided by f of n, no, 1 divided by, C2 is greater than or equal to f of n on this side. But we want to show that factoring going on. So I'm going to copy this guy up here, paste it right here, change this C2, change this f of n, and come over here, change this C2, right? So we're just showing that this goes both ways with going from the big O notation, refactoring it into big omega notation, and proving that g of n is in O of f of n time, and then having an omega function in the inverse, with the inverse functions and constant for this circumstance, and then doing the same refactoring and then showing that g of n or f of n is omega g of n time, right? So let's go ahead and continue here. We say that this remains constant here. This portion of the function, or the inequality, and then on this side just becomes f of n, right? So then we'll take over our definition, copy this here, we factor big omega definition to reflect big O, right? And then we'll say, because we have now inverted C2 as 1 divided by C2 to fit the big O definition, we can now say that, say that C1 divided by C2 is equal to C2, right? Or is equal to C1, I'm sorry. Perfect. So then we'll just say that the g of n times some constant C2 is greater than or equal to f of n, which this satisfies the big O definition. And then we have so sorry, this should be omega and then this should say now that O of g of n is equal to f of n. Perfect. Awesome, we got some comments. Ozzy Rivera, thanks so much for joining and leaving me a comment. I appreciate you joining the stream. Hey, brother, been watching your videos. I'm currently in your boot camp. Awesome. Well, that's good for you, man. I appreciate you joining and wanting to learn along with me, and that's super cool that you're learning through a boot camp and doing what you can. What kind of stuff are you learning right now? Where are you at? What languages are you learning? And how far along are you? Appreciate you joining. Thank you. Cool. That satisfies this problem. Let's go ahead and move on here. R 3.16 key.py. All right. I appreciate you guys watching the videos. No, honestly, I'm going to, after the stream tonight, grind out. I think I'm gonna do a video. I'm gonna record a video tonight after the stream for one more of the Python crash course. I'm gonna do another Python crash course, try it yourself solution video, and then I'm gonna do a demonstration video for the task tracker application, just so we have it on the channel as like a published video showing like, hey, this is what we did. So if people ask about it in the stream, we can say, oh, go check out that quick video, and you'll see it rather than having to pull it up every single time. And people can see like, oh, this is a beginner project, and maybe they can model it after, because I know a lot of people look up beginner projects in Python on YouTube. So kind of like similar to my CS50P final project video, I'll just do like a little summary demo video of the task tracker app. All right, so cool. That was that problem. Let's go ahead and move on to this one. Show that p of n, we got a new function, p of n, is a polynomial in n. Then log p of n is O log n. Oh boy. Oh boy, everybody, we are getting to it here. Oh boy, oh boy. Show that P of n is a polynomial in n. Then log P of n is O log n. So how would you express... Ozzy Rivera says, I'm going through the Python Crash Course book, 3rd edition. I was getting confused on some of the do-it-yourself work. Your videos helped me get through some. Dude, yes! I was so happy that is what they're doing. That was the whole goal of them. So I'm happy that is working and that people are finding those useful. All right. So how can we show that P of n is a polynomial n? Then P of n, log P of n is O log n. So let's go to our polynomial definition. Ooh. Okay. Where are all my polynomials? Okay. So most of the functions we have listed so far can be viewed as being part of a larger class of function, the polynomials. A polynomial function is the form of... Okay, so we need to show that P of n, polynomial of n, is equal to n naught, no, a naught, plus a1 times n plus yeah, okay, let's keep going here. Let's keep going. Don't give up here, Mike. Don't give up. N to the power of 2. So, sorry, this should be a2 times n to the power of 2. I'll copy this over. Paste. This would be 3 and 3. Then we'll paste dot 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 plus a d 2 times n to the power of d, right? Okay, so this is the polynomial notation for a function p of n. So now we need to show that the log p of n is O log n time. So let's take the log of this function then. Let's copy this down. Delete this. Ooh. So let's take the log of this. If we take the log of this, oh gosh, do we take the log of the entire side? This is, that cannot be directed at me. I'm just talking. You guys hear that banging? I know that ain't at me. I'm just talking up here. Whatever. So we have log a sub 0. Okay, so you guys are gonna have to refresh me here on what we do with logs. Oh my god. So these are called coefficients, right? Up to the degree. For example, the following functions are polynomials. F of n is equal to n. So I guess we could have just said, oh my god, really? We could have just said f of n is equal to n. That's a polynomial, yes. We know that. So if we just log, or sorry, this is p. We just log this guy. Log n. So what would this, if we log p, right? This isn't O of n time, I would think, right? We have some constant a, like, up to the nth degree. What do you guys think for this one? If p of n is a polynomial in n, then log p of n is O log n. Does this just not prove our point right here? So if you log this, you would essentially be logging everything inside of the function, right? Every addition gets logged. Let's go like this. Log x plus y plus z. Reduce this. Note there isn't a generally simplifying the further. Yeah, okay, it just becomes log x plus log y plus log z. Oh, no, you can't. You can factor out. Interesting. So let's take this problem. If you have p of n is equal to n as a simple polynomial, logging, taking the log of both sides would just be log n O log n. Your reasoning is on the right track for the simple cases of p of n, but let's generalize it to show that p of n is of any polynomial. Okay, so we need to show this then. So we have log p for any polynomial, like this. Here is my notation. That's an excellent starting point. Let's continue working with your notation. The dominant term. For large n, the term with the highest degree dominates all other terms, right? Yep. As n reaches infinity. My network connection was lost. Weird. Okay, dominant term. Right, yep, we know that. For sufficiently large n, we can approximate we can simplify this down. Okay, that's what we do. You'd simplify this down to about, okay, for sufficiently large, for large n values, we can infer, we can assume that the above polynomial will result in let's write this here. So if we take the log p of n would about equal to the log of a of that to the highest degree of the polynomial times n to the highest degree of the polynomial. So what this is saying, guys, is, for sufficiently large n values, this high degree polynomial is going to be so large in value for a times, for this constant times this our value. So if our n value is like 1,000,000, and we have a very large polynomial here, obviously, because we have a very large n value, our degree could be very large too. So essentially, we could infer that or assume that this would be like true in most cases for sufficiently large n values. It's just going to, the log of p of n is just going to equal to whatever the log of the coefficient to the highest degree multiplied by the input to the highest degree of the polynomial. Now, I wonder if there is some mathematical way to determine the sum of all the preceding values based on this value, but that'd be interesting. Ooh, pop my back. So simplify this using logarithmic property a and b. So we can simplify this now even further, right? To say that log p of n is going to equal about the log of a to the highest degree of the polynomial plus the log of n. And as you can see, this is going to be some constant value plus the log of n. I think is what it's going to say. Oh no, so we have to the power, we have to the power of d. So now we can factor this out even further and say that log p of n is about equal to the log of the the constant of the highest degree for the polynomial plus the exponent out front. Per our exponent rules, we can take the exponent within our logarithm that's being multiplied by our base value, not our base logarithm value, right? This is log base 2. I should probably add that in for clarity's sake. Because this is computer science, so we are using log base 2 for these functions when determining time complexity, unless otherwise specified. Okay, so now that would be, we would drag out that exponent out to the front of our function and make this times n, right? So this now would represent some constant c times our time complexity log n. So log p of n, actually, because this is about equal to this, right? Oop, let's take that. Because log p of n is equal to this, they take this side of the function and they actually paste it down here for log p of n. So we can simplify the log simplify the logs, right? And so this results in a right, that's our polynomial, that's our p of n value is equal to or they rather just did it like this. They just showed p of n, the log p of n. Right, is equal to O log n time. Cool. Hey Dipper ID, I appreciate you joining me tonight and studying. I appreciate you coming in and leaving a message. How you doing tonight? All right, cool. That answers that problem. All right, great. It likes our reasoning. Boom. R317 underscore key dot pi. Okay, let's go ahead and head back down here to the end of the chapter 3 and take this guy and we'll say boom, 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 boom. All right, show that n plus 1 to the power of 5 is O of n to the power of 5. Okay. Interesting. This sucks. So we need to say O of n to the power of 5. Man, this you do need to know and be fresh on your rules for exponents and stuff. I think they have examples in the book, but yeah, it's interesting. Okay, so we have. Hey, Dat Steele, I appreciate you coming in again. Welcome. How you doing today? Okay, we have. Uh, cubic functions, or sorry, this is going to be. So these are polynomials still. So we need to show that n plus 1 to the 5th power is O of n to the 5th power. So in 316, we had our polynomial. We took it to the highest degree, right? Chillin' LO just finished calc because homework to watch your stream. Oh, nice, cool. Currently doing the chapter 3 of the do-it-yourself work. I like to try it out myself and then see how you solve them. Yeah, Ozzy, that sounds great. I haven't. I need to post more of the try-it-yourself solutions. Um, I only have the first 3 of chapter 3, so tonight I will hopefully have the next videos up after the stream. I'm gonna make some. You're holding me accountable, Ozzy. You're making me need to do it. Thank you. Okay, anybody have any idea how we could go about solving this one? So if we have to the power of 5. So to simplify, we can expand it using the binomial theorem. Okay, we don't need to do that. Okay. Oh, so you just plug in. And minus. Okay, so you do have to go through the binomial theorem here. I'm gonna be honest, guys. Oh God. I'm gonna be honest. I don't really remember this from math. Oh my gosh. So the binomial theorem is so if you have a plus b to the power of n is equal to the sum of all values starting at k equals 0 all the way to n for all values n divided by k. What? For whole. My calc textbook used the binomial theorem as a way to prove a derivative rule. I honestly just skipped it. Yeah, that's how I'm feeling right now. I'm like, oh God, freshman year calc coming back. I don't remember this. So you would have to expand this out, Jeremy says, to n to the fifth plus 5n to the fourth, 10n to the third. How did you do that so fast, Jeremy? Do you have a secret way of doing this fast in your head? What did you do? So is there a secret way of doing this essentially besides obviously this summation here? So sum all the numbers of. So you just take 5. So for k equals 0, you do 5 divided by 0, which you can't do. Oh, what is this? I believe it's just a pattern. There's a pattern to make it easier to remember. What is the n over k? The expression n over k, also written as is known as the binomial coefficient. It represents the numbers of ways to choose k objects from a set of n objects, as it reads as, quote, n choose k. It's a key concept in combinatorics. Combinatorics. Oh my gosh. Whatever. So factorial n. Jeez, how did you do that so fast then, Jeremy? I asked Google to expand it. Okay. I don't think that they're gonna ask us in any sort of maybe interview questions or thing to expand a polynomial. So maybe we can get away with just asking Google to expand it for us. So let's go ahead and take this. It's kind of a hack, but it's whatever. Okay. All right, so that gives us this. I should probably preface that uh, I asked AI to expand this polynomial. Okay. We'll preface that. All right. Then we'll say, so the log of n plus 1 to the power of 5. Here's what my calc textbook says. A plus b to the power of 5 equals a to the power of 5 plus plus 5 times a to the power of 4 times b to the power of 2 plus, oh my god, this message is hard too. So is equal to a to the power of 5 plus the power times the power value times a to the power of 4 times b to the power of 2 plus 10 times. So you always get these coefficients then, plus b to the power of 5. Okay, so we'll take this and we'll cover it. We'll go below that. All right, cool. With that, Muna, thank you for coming in clutch and giving us a quick little representation here of what we could do to just plug in, use to expand the polynomial. Right? Muna just made it so we could get rid of the AI statement. We have now a little hack here from the textbook where you can raise these. You can expand this polynomial by using this kind of format here. So it looks like these coefficients remain constant for these values. They don't really interesting. What's up, man? I appreciate you joining. Thank you so much for leaving a comment. And what's going on tonight? Muna says the exponent of a term decreases while the exponent of b term increases in the general pattern. Oh, gotcha. So we start off with 5, then we go down to 4, b goes to 1, 2, a goes to 3, b goes to... Muna, are you supposed to have b to the second here as well as b to the second here? I believe the coefficients aren't usually 5, 10, 10, 5, blah, blah, blah. I think it's since it's raised to the 5th power, you take the coefficients from the 5th row of Pascal's triangle. Oh my gosh, there's a lot of math that I have forgotten about. So what would go here in this place, Muna? Be b to the 1st power. Would it be b? Jeremy says there's a simple way using combinations, but it's just impossible for me to explain in a YouTube comment. Yeah, and we probably don't need to go down into these math rabbit holes just yet. You know. All right, we're just waiting for the correct value here. We have 2b squares here. Where shouldn't we have? We should have b to the 4, b to the 1st here, b to the 2nd. So this should just be times b right here, right? Yeah, it should just be b right there. Because this will be b to the 0. This is a to the 0, which is 1. Yeah, b to the 1st. Cool. All right, so let's go ahead and what's next? We have to say that so this is going to be to the highest degree of the polynomial. So this is going to equal log of n plus 1 to the power of 5 is equal to is about equal to, right, log of n to the 5th, right? This is going to be 4 large values of n. Well, n to the fourth times 5 might be pretty large too. But let's see actually. Let me go let's test this out, you guys. Let's put in Desmos here. Let's go and just type in, like, for a large value, like 1,000 or like 20,000, right? Let's do to the power of 5. Okay, let's do 20,000 to the power of 4. Now let's put a 5 out front. So still is 4 magnitudes of domination lower than the top value. But pretty large in itself, right? That's a pretty large value. But still, this one is very large, even more so large. Okay. So, that being said, we can simplify this to 5 times the log of n plus 1 is about equal to the 5 times the log of n, right? And so these 5s essentially would what? Just cancel out to log n plus 1 is about equal to the log of n. No, can you factor out like this? I don't think so, because it's actually just asking for is O of n to the 5th power, which would essentially be I need to refresh my knowledge on logarithm rules. Yeah, me too. You're telling me, my friend. You're telling me, that's for sure. Oh, the stream is lagging a little bit here. Why is it dropping frames? I'm like the only person. Again, it's like really cool right here by this window. All right. So, right, we could bring the 5 out. This is the same. Log n plus 1. No. So you log this side and log this side, you would get essentially this. We can put in, right, this part. So what are we doing wrong here, though? That's what I'm not really understanding, is that we are. So show that n plus 1 to the power of 5 is O of n to the 5th power, right? So what do we do here? We did that, we reduced it down. We showed that with log n. Anybody have any ideas out there what we're missing here? Wasil says, any tips for an interview I have? Interview for Google coming up. No tips for me. I've never done a software engineer interview. I have a degree in human biology and a minor in chemistry. I graduated in 2021. I've been working as a formulation chemist professionally for a little over 3 years now, and I'm learning coding as a skill and an additional um, hobby, and just using this channel to document my progress and to help others that might be in a similar situation, or motivate others that are also learning to code and creating an environment for this kind of situation. So yeah. So unfortunately, no advice from me besides just be yourself in the interview, I guess. Good luck. All right. So what are we doing wrong here? So is this all we needed? Is that it's O of, right? We don't need to log like any further? Is this it? Right? Is that all we needed? Was this? You're on the right track. Let's go step by step to show. Let's expand the polynomial. Compare the growth rates. For large values of n, the dominant term is n to the fifth because as n goes to infinity, the lower order terms grow much slower compared to n to the fifth. Thus, the expression behaves like n to the fifth for large n. We need to show that there is a constant c greater than 0 and n not such that for, okay. From the expanded form, so we have big O notation. From the expanded form, for large n, the term n and 10k and 1 become negligible compared to n to the fifth. Specifically, we can bound the polynomial as follows. Oh, so you add up all of the 1, 6. Okay, so you add up all the coefficients out front. Thus, we choose c equals 32 and equals 1 to satisfy the big O notation represent. Conclusion. Interesting. So, okay. I'm not sure how we would have figured that out by ourselves, but I took it one like this. I did this. You're on the right track with this approach. Let's go step by step. Okay, you're on the right track with your approach. Let's go step by step, make sure everything's clear. Expanding, and we can expand to the polynomial, right? This approximation, and just taking a logarithm of both sides expands to 5 log n plus 1. For large values of n plus 1 is very close to n, so the logarithm of n plus 1 and n have similar time complex, behave similarly, okay? Thus we have, boom, conclusion. Since log n to the power is about equal to, we conclude that, in other words, the growth rate is asymptotically the same as 5, n to the power of 5 as n become large. Okay, so we did prove it here then, I guess, in a different way. We broke it down and showed that log n is equal to, is about equal to the growth rate of log n plus 1. So we can say that all of these are about equal to each other, and grow at the same rate. Which is interesting. Vance says, yo, what's up, brother? You hit 300. I know we hit 300. We are blasting off here. It's super, it's super interesting, that we were able to get 300 super fast like that. So let me go ahead and open up YouTube here. All right. Yeah, we're at 3:35, you guys. That's so cool. All right. Okay, let's go ahead and let's wrap up this problem here and then we'll shift over to the project, okay? So what they did earlier was they showed um, grow at the same rates. Is my method wrong? Your method is not wrong. You're right on track and your reasoning is valid. Let's break down your approach again and verify the steps you took are correct. Is true dominates, right? This is correct because you're taking the logarithm of both sides. Simplifying the logarithm is valid because negligible. This is valid for large n. The difference between becomes negligible as they're asymptotically equivalent. Concluding. Okay. Let's take this. So our answer is right here, guys. I want to take the reasoning. Oh, come on, stop doing that. Control C. Okay, there we go. Cool. All right. Ray 3 says, "What about the project again?" We're about to dive right into that right now and work on it right now. I don't really know anything about data structures or algorithms, so I don't understand what the time complexity of a function is. Gotcha. No worries. All right, got to go finals this week and next week. No worries, Vance. Good luck to you. I appreciate you stopping in and saying hello. Good luck. I got OOP and computer architecture and organizing final this week. Hopefully, I clutch up. Interesting. I wonder what the object orientation final is like. What do you have to do for that? Do you have to code, like live coding, or what? Answer questions about instance variables and stuff, or how would you test for that? It seems interesting. Omar says, "What's the best way to learn your opinion? Books or videos?" I think everybody's different and can learn it. My connection keeps going up and down, but sorry if it's kind of glitchy sometimes. But I found the best way for me is doing these streams, right? I'm talking through these problems out loud, repeating myself over and over and over again. Yeah, I'm getting annoying. I might be getting annoying to myself, but I don't really care. I'm learning this material. I don't care if I'm getting annoying. I don't care if I'm taking too much time. I'm learning this material. I'm learning it at my own pace, and I have people that are willing to follow along and watch that, and because they are probably liking the pace at which I'm going and that I'm actually getting these information in depth and covering it all rather than just getting gaps and skipping over things for an exam like you would in college, right? I think that's the downfall of college is that you have so much material and so little time that you're forced to move on, and you're forced to have cracks and holes and to make jumps over certain concepts, just for the sake of time. Whereas now we're completely independent. I don't have a professor to account to, or to hold me accountable. I'm doing this on my own pace, and so if I don't get it, it only hurts me myself to move on. I have that motivation to, for reinforce these concepts, because I don't want to just limit myself. Why would I want to hurt myself further? I want to, be the best version I can in this. So yeah, hopefully that's kind of cringy, but it's true. And I like to read. I think reading applies. I mean, the videos are really nice for going back and solidifying the concepts, but the reading helps to really introduce those needed concepts. There are these books here for a reason. They've stood the test. Ah, my connection is glitching out. Sorry, guys. My internet keeps going all over the place, and I don't want to get stopped in the middle of a subject that we're talking about and have it get all broken up. Okay, so tell me if the connection starts going bad and if you guys can't hear me or something. This is so ridiculous. Come on. I don't know why I pay for high-speed internet. I'm the only person that uses it. Doesn't make any sense. Um, all right. Hopefully it just will correct itself here. Come on, guy. Figure it out. It's only the video. We can still hear the audio when it freezes. It's only the freezes for a second. Okay, I'm sorry. Okay, I appreciate that feedback. Then I'll just continue talking, and I'll so I don't get boring here. But I just wanted to make sure things were still working out. Okay, so um, Tracoso says, what does O of n fifth to the fifth mean? Is it the same as O of n squared? The quadratic drops the constants. So it would just have the time complexity associated with a function to the fifth power. It would be the similar in the sense of a, quadratic, but it would just be even more, have a even faster growth rate, drastically by a magnitude of 3x more, right? Um, for whatever the base unit is. So it probably would be even larger than that, but um, or 300, yeah. So yeah, it would just have a steeper overall growth rate, but still be classified in that same realm of function. It's not an exponential function at that rate. It's still in that quadratic, cubic realm area. I think. I can't. I don't know what is the fifth power called. I'm not even sure. Man, my internet is all over the place. This is annoying. Let me make sure I'm connected to the right one. Yeah, I am. All right. Vanch says we have UML diagram and design pattern for this one. Write code on paper and multiple choice questions for some of them, but 50% is just pen and paper of UML and design patterns. That's the best thing about self-learning. You learn at your own pace. Exactly. So many arrows with their special purpose. It only freezes. We can still hear audio. Freezers. Okay. All right, you guys, let's go ahead and shift focus here. We completed um, 3 problems. Not that many, but these problems are kind of hard and long. They take a lot of writing out to kind of wrap our heads around here. But I mean, what would the next problem be? Is it that hard? So we just get into a exponential function, and then we need to show a n log n function. So just more of these show things. Okay. Let's just go ahead and let's move on to our project. I think that's what people want to see for right now. Okay, everybody. Actually, we need to, let's go ahead and push this, right? Okay. All right, we'll push that up. Cool. Omar says, I'm working with data structures and algorithms too, but in Java. Never had this much trouble working, understanding a concept before. It's not as easy for sure. Yes, definitely, right? It's a doozy, so give yourself some slack, cut yourself a break, you know? It's going to take some time, so take the pressure off. Okay, so last time we worked on this yesterday, we discovered a little bit of an error. We need to actually remove the quantity attribute associated with these item, right? The item on, if you think about it, the item is an individual instance. It's a singular object. So that's how we need to treat them, unfortunately. We can't, in my vision for this program and for the purposes that I use it, will use it for my small business, is that quantity is arbitrary to the individual item by item basis. It is a factor that is applied to if you end up getting multiple of that item, then you can scale the item times whatever the quantity is. But you don't want to have an attribute associated. So I'm going to actually remove quantity in all. Boom. It's done. Quantity, goodbye. Okay. So then we will take quantity out of here. Oops. We'll take quantity out of here. We'll take quantity out of here. And we'll take quantity out of here. Right? Now, that just tells us, you know, okay, so now what we can do is, before what we were doing is we were trying to get the quantity here. We will not ask for the quantity here. We will not use the quantity to create objects. So we're going to append the item to the list. So what we're going to need to do actually is I want to take quantity here. I want to get quantity, but I don't want to have it here because it's not an object attribute. I want quantity to be here, and we'll say, well, we will ask, try to get quantity from the user. If quantity so we will say I don't think we need to say try. Unless we try to loop this. We'll try loop. Python, you can use try except block or while loop depending on its position. Can you use continue after the except to try again? Yes, you can use continue after the sec block to restart the current iteration of the while loop or for loop essentially. But I don't. Okay, so you have to have the while. The try doesn't essentially loop. That's all I wanted to know. Like we've been doing before. So we'll have to say while true. We want to get a quantity from the user. Try to get a quantity from a user and convert that to an integer. Except if we get a value error. Or is it value error or type error? Would int a stir with alpha give a type or value error? If you try to convert a string, you will get a value error, not a type error. Okay. If except value error, we want to continue. I'm going to print. Okay, please provide whole integer, continue. So if quantity so we'll break here. We'll say if quantity greater than 1, do the following. What we need to do is, right, we only saved the current item number here. So if quantity greater than 1, we need to go, so quantity will give us an integer, meaning how many there are, including the current current 1. So okay, so so what we need to do is if it's greater, if quantity that they provide is greater than 1, if they provide a quantity that's greater than 1, we need to then, sorry, my brain is not working right now. It's been a long day, guys. For those of you who don't know, I graduated back in 2021. I have a degree in human biology and a minor in chemistry. I specialize in the chemistry aspect of human physiology and things of that nature. I currently work as a formulation chemist for a biotech company making biological controls for patient diagnostics in in clinical settings. Um, you know what physicians would test their patient samples against to compare for making proper diagnoses for diseases and various ailments. I make a lot of biological solutions, and I'm learning to code in my free time after work to gain further skills and uh, further knowledge and just push myself and do something I know I can do that's challenging. And so if you're following along and you're new here, thanks so much for watching. I appreciate you guys joining me. The stream has been doing really well the past couple of days, past week, and We've been growing quite rapidly, so thank you so much. I also have a Discord linked below where, pardon me, I conglomerate all my study resources into one location, and I provide that to you guys free, no charge, no nothing, just wanted a central area for everything to be, so you guys could also follow along there. I provide all the PDFs for the books I'm reading, for references, things like that. All right, so if the quantity that they provide is greater than 1, we need to um, create a method here for um, increasing the item number um, associated with the quantity. Um, so we need to say for value in range of quantity. So this will give me we'll say so for every value in the range of the quantity. So this will give me some 0 up to the quantity. So this will capture the actual index values essentially, or the places in the that the quantity is needing. So we capture each one of them for item. We'll make it consistent for item in quantity. We need to so we'll say for I in quantity. Oh god, guys, oh god. For I in quantity, the range of quantity, so this will access 0, 1, 2, 3. So let's say the quantity is 5. Well, now we'll loop through. We need to say quantity is equal to so this will have to be in our loop then, right? So this will have to be within our loop because we want to make a item for every quantity, right? So we want to make an item for every quantity, and then we initially need to Hey, Danker owner, thanks so much for the comments. I appreciate you chiming in. But we do need to loop here. I don't think you understand what we're trying to accomplish here. We have items, and we have a item number attribute that's being assigned to them. So we need to reassign the item number attribute for every integer in the range of the quantity. So for value, so if we give 5, this will give us physically. So I in this case, so if quantity is 5, we'll say I in this case would literally mean 0 for the first one. So this will be the first spot. So for I physically would house the integer 0 for the first one, right? That's just the first place, indicating the first quantity item that would need to be created. So we'd have to create this item, right, from the 0 place. And then we need to take so what we're going to do is, instead of item number, generate item number up here, we're going to take item number from down here. Date created will stay, so item number will come down here and say, so new item, we're going to generate the new item. And then for it's throwing me off here. So then it's going to say for value so if we want to say for integer in the range of the quantity, so that'll hold the zero place or hold the place value of the quantity itself. We need to then create the item in that place, in that section. We need to first generate an item number. So item number is equal to generate item number. So we're going to generate item number. We're going to create the new item here in this space, right? So what this is saying is we have the range of the quantity. Okay, I'm going to try to show you guys what's going on here. This is going to help. Okay, let me bring up this whiteboard. Can I delete this? Yes. Okay, so let's say that we get a quantity, oh God, is equal to 5. So we want to create 5 items equal representation from this run add item section, right? So we're going to say if quantity less than or greater than 1, meaning that they provided more than one item, we're going to take a placeholder and say for I in range, I'm just going to hyphenate this, sorry guys, I'm using an Apple Magic Mouse, so this is rough. So for I in the range of the quantity, so if this is 5, so what it's going to do is essentially it's going to create placeholders. So we have a placeholder of a 0, a 1, a 2, a 3, and a 4, right? And so, that 4 is awful. There we go. So it's creating these. Think of these as like cells almost. They're not physical. These are physical values, right? But we're tracking kind of like indexes of this quantity. So think of these as like cells that we're going to then generate and place a. We could essentially, rather than saying for value or for I, we could just say for underscore, because we're never going to use this again, right? So that might be a better way of saying it, for underscore in the range. So you can say for underscore if you want to just say like some arbitrary placeholder or some placeholder variable, but underscore would work in this place because think of it as like a cell that we're going into. So rather than 0, 1, 2, 3, 4, 5, we're going to have 5 spaces, right? Underscores, physical underscores, but this looks like spaces that we're going to place, or boxes, cells that we're going to place these items into, these generations of these class items. So for R in the range of the quantity, we're going to generate an item number based on the current values of the list, right? The generate item number, all it does is look, okay, are there any items currently in that section of all items, the items key, the list value for the items key. Is there any items in there? Okay, if there are, let's go ahead and find the last one with the -1 index, and let's go to its item number and let's increase it by 1 and save that so we can make a new item number, right? That's all that does. But what this is going to do now, where was I at? Where was I at? Oh gosh, where was I at? Here we go. So what this is going to do is it's going to generate the item number. It's going to create the item number. We then are going to append the item. We're going to, it's going to generate the item number. So now we have an item in here, right? Through the first iteration. Now we have an item right in there that we generated. So then we're going to go to all items, right? We are going to go here, go to the items key value in our dictionary. We're going to dot append, because this works because the dot append method works on lists, and the value associated with the items key is a list, just by what's going on under the hood. And so we would say append new item, right? So this is going to append the new item and then move on to the next block. So right, so we have quantity is equal to 5. If the quantity is greater than 1, meaning that we want to duplicate this item 5 times, we need to generate 5 placeholders. We need to create an item here, right? We're going to create the item through this line of code here, line 132. We're going to take all of those informations that we asked the user for and plug them into our instance variables here and create the item. We are then going to append, so we created the item and then we're going to append the item to the list. Now it's going to move on to our next spot in our blank here in our loop, right? And then it's going to say, okay, we need to now generate a new item number because we just loaded that one into the list already. So now we need to go to the next item and then create the item and move on. And boom, we're going to move on to the third spot that's available. We're going to generate a new item number and we're going to create the item and we're going to append it. We're going to go on to the fourth spot, generate a new item number, generate the item, append it. Move on to the fifth spot, generate a new item number, generate an item, and append it. And that's exactly what's going on under the hood, guys. Woo-hoo! We're cooking now, boys. We're cooking now. That feels good. Okay. Jeremy says item number is an ID or the quantity of items. No, item number is just an ID to track, like, oh, I sold item number 1. Boom. Pull it from the system. Oh, I sold item number 256. Boom. Pulled from the system. Oh, hello, Gina. Appreciate you joining. All right. So hopefully that loop outline made sense for everybody, right? So we are saying for every space in the range of quantity, we're going to generate a new item number, generate the item in that space, add that item number to it, and then create and add the item to the list. So I can delete this here. So let's go ahead and try this out. Thank you, Runner. I appreciate you joining and leaving a message. No worries. I appreciate the comments and all the help. I know I more than want involvement and if I do something wrong or screw up, please let me know where I messed up. I want to improve. I want to get better. So Jeremy says, so you won't be constantly overriding the lowest item numbers? So won't you be constantly overriding the lowest item numbers? No, because the generate item number function here that I'm calling, what it does is, so we append, right? And then we call generation in the next iteration of the for loop. And the generate will go based on that recently appended item. So, right, under the hood of the generate item number function, right, all we do is try and access the last item in the item number which is associated with the last items, right? We go into our all items dictionary, we grab the items key, and we find the last value in that list if there is one, and we grab the item number from that, and we return last item number, right, +1. Except if we get an index error, meaning that there are no items in the list, we return 1 to start off the list. So for what's going on here is we go through the loop once, we generate a new item number based on the previous loaded items or anything that's already in there, or if it's blank or whatnot. We go ahead and make the item based on that new generated item number, and then we add the item to the list. We go through the loop one more time, again, we generate a new item number, right? Because we are iterating again over, or we have already added that item previously, this item will now be the new reference item compared to the last, I believe is what will go on. It won't override, right? Because it's appending that and then generating a new item number +1 in between each iteration. So it won't be overriding, I don't think, right, Jeremy? We're increasing or incrementing our item number by 1 for every iteration of our quantity, of our range of our quantity. What do you think about that? Let's try it out. So we have items here. Let's go ahead and delete all the items in our thing here. Let's go ahead and run the program and let's try it out. So let's go ahead and press 1. Oh, we're at an error already. For sale item expecting quantity in. Okay. Oh, right. I have load file. Shoot, I need to edit those functions. Yeah, generate item number is a function we have put in. Okay, so we need to actually update. We have these functions, the load file, right? So we need to remove these quantity lines of code. Oh, but those are gonna change these. That sucks. Okay, this is gonna take a second, guys. So we gotta be smart about this. So quantity goes away. This goes down to 3. This goes down to 4. Okay. Quantity goes away. This goes down to 3. This goes down to 4. This goes down to 5. This goes down to 6. Quantity goes away. This goes down to 3. This goes down to 4. Down to 5. Down to 6. Down to 7. Down to 8. Quantity goes away. Quantity goes away. And quantity goes away. And then we got to remove quantity here. Remove quantity here. Remove quantity here. And then let's go ahead and I'm going to Command F for search for quantity to make sure we don't have it anywhere else. So we have it here. We need to remove this quantity here. Remove this here. Index 3, index 3, index 4. Remove quantity here. Remove quantity here. 3, 4, 5, 6. Remove quantity here. Remove quantity here. 3, 4, 5, 6, 7, 8. Okay, let's check for quantities anymore. Okay, those are the only 4 quantities. Check for quantities here. Okay, so we have this repr that needs to go away. Okay, and no more quantities in this file. Okay, so I think we are good to run now. Okay, let's try to run, guys. Okay, we'll press 1 to enter in. Oh boy. Okay, I need to, hold on. I still have these old files with the quantities in here, so what I'm going to do is I'm just going to delete the files because they get auto-generated if you don't have them. We wrote that in. So delete, delete. So now if I run, boom, we're in and we got those files back. Okay, cool. So now let's see what happens. Okay, so if I go inventory by pressing 1, if I press add item, I go item name. We'll say this is a Calvin dress. Cost of the good was $10. Item size is medium, right? We set up the item sizing portion last time. Use today's date, yes. Quantity, here we go. We'll say, let's do 10. None, okay. Object not scriptable. Okay, so we got an error here. Unfortunately, we need to check the generate item number. It doesn't like that it can't find a none type. So it wouldn't return an index error. Index error, type error. So a none is not scriptable. Okay, so it didn't have the list yet. It should have had a list returned to it that was empty if there was nothing given to it. So load file, except file not found, write these. Oh, okay, so if the file isn't found, we return a list for all of these. So what we need to do is, if the file is not found, we need to say, right, if the file, so if it's items, we do that. L if it's for sale, if it's sold, and then we need to say here, except with open reader if elif return empty list, right? So now if we run this in type 1, inventory add, dress, cost 10, item size is medium, yes, quantity 10, boom. Okay, that did something, guys. That did something. Hold on. Okay, nobody move. Okay, so now if we exit out of the program and save, we should have 10 items duplicated in our items file here with an incrementing item number for every single one of them. So if I go main menu, exit, yes. Oh! We did it. Good job, you guys. Let me get some more lemonade. Woo! I'm feeling good, feeling good. We got that to work. That's so awesome. All right, so what we were able to do, guys, is now we had to obviously fix some things. So before, we found a bug where if we weren't getting the file right, we were generating the files and creating the headers for each of the files, but we weren't returning an empty list, so we were getting none. So we added that right there, and that fixed that. Peyton, thank you so much for the kind words. I appreciate you. Thanks so much for stopping in and leaving a message. Yeah, we couldn't do it without the chat here for sure. You guys are supporting me, keeping me motivated. My hair's going crazy, but oh well. Thank you so much for the support, you guys. We got 16 people in here. I appreciate you guys joining me, spending your valuable time with me, learning, improving upon yourselves, doing what it takes to put yourself first and, learn hard things. And, you can learn hard things. You can do hard things too. So we're doing that together. All right. So just to show you what's happening here, one more time for those that might not have known what we did. So let me catch my breath. I'm excited. Woo! Woo! Come on, chill. Okay, so what we did was yesterday we realized that right, we were creating items on an individual basis, right? And we were having a clashing of definitions going on just in our own program, like in our own internals, what's going on under the hood. Not anything between variables clashing, like type errors and stuff. Nothing like that, but just definitions of what our program was doing in our own like ideas, right? So the item um, was a singular object, and so we were associating a quantity attribute with item. Now you can do this, right? You definitely could do this, and you could make it items and make it a little bit more modular. But we kind of brainstormed how that rabbit hole would look, and what me in the chat and people like Jeremy and everybody what we came up with was that the you would have to have like dictionaries be associated with these values, and then have keys and values associated with the quantity and the count and things like that. And so it would just get difficult because then each would have like maybe a different cost of the good, right? Um, Maybe it was created on a different date, and so you could, yeah, you could house one individual item with a ton of varying attributes associated with it. Like we could make it just a master item, and then it would have every item with all their dates created, all of their costs associated with them, and it would just be ordered by like the cell columns or things like that, or maybe, or for the specific lot number of that item number. So you could break it down even further, but that just seemed kind of like a rabbit hole that maybe we didn't want to go deep down. We didn't need to expand that far. HX said, I read the title as Touching Myself Python. Bruh. That is funny. I'm really enjoying this. Ajax, thanks so much for joining and leaving a comment. Appreciate you coming in. We just successfully added in a feature here, and it felt really good, and we got that rewarding feeling. And so, yeah, we're feeling juiced right now. And he came to check it out. Yeah, what does that say about you, Ajax? You clicked on it, man. Oh boy. All right, so what did that essentially change? So, right, we needed to remove the quantity for the item. We needed to remove the quantity for the for sale item, which we were supering from the item, and we needed to remove the quantity from the sold item, which we were supering from the super, right? So that's where it was coming from. We then needed to remove the quantity from the obviously all the load file, which just reads the quantity that we had previously. We needed to remove it from all three instances. We need to remove it from the headers that was being displayed or being generated on a file that wasn't already present. And we had to remove the quantity attribute for the actual saving of the file so that we could maintain our order of our properly, right? So, but we still wanted to allow the user to create multiple instances of that same item, right? Just because you have that one item didn't mean that you didn't buy maybe 5 of it. Let's say you went to the store and you found a really good deal on some staplers that you wanted to maybe resell online or something, and you got all 5 of them at the same price right that day. Well, you would go into the system and you would create, and rather than maybe having to go through that add item process every single time, we now added a feature to bulk add items, right? And so we moved that quantity attribute outside of the class itself, and made it an integer that would just multiply the object creation by how many the quantity would be, right? So what we did was we wrote in right here in our add item function, right? This is getting kind of long and elaborate. Over the course of the days, we've really started to expand on this function, write it out. We probably could optimize it further and maybe make some more functions, but obviously we have functions within here that we've already optimized down. So this is just kind of the bare bones essentials of what actually is kind of just getting inputs from the user and stuff. So it's not really like much we can refactor down here. It's just kind of getting that necessary information to add the item. So like yesterday, we obviously added in the sizing tuple, which restricted the user to actually matching an available sizing unit for this item. Now we might need to add in a way for the users to override these sizing constraints for their things. What if they do it in inches, or they're selling like tools that come in like 3/8 or whatever. Like exactly. So they would need different sizing constraints that they could maybe override with a function that we could implement. So we'll have to think about that. Um, so what we did to kind of fix this whole quantity situation was right here is where we start actually asking the user for values to or right so right when we run the add item function, we ask the user what is the item's name, right? We just ask them that. Um, then we enter this while loop and we ask the user for a cost of good. Um, Now, what we did is we needed to account for the strings input. So if the user were to maybe input strings or something like that, we wanted to, you know, get that raise an error and have it send back. So what we did was we first checked to even say if the user entered a value. So if they just entered through the prompts here, they would need to enter a value. So if they enter a value, um, if they enter a value, we detect if there's a period given in like dollars and cents format, dollars dot cents format. If there is a period, we're going to go ahead and split on that period, and we're going to save those values in these variables, the left and the right of the split. We're going to try to convert these variables into integers, and if we can't do that, meaning that they entered in like quote 2 as in literal two.50 fifty or 20 or whatever, they would be flagged if they added in a period somewhere in here. So that solved that issue, but we needed to also handle if they just added in the whole integer value as a number rather than, so we need to keep that in mind as well. So we raise that error if they don't properly give us the notation with the decimal that we want. Now if we then all we do is just convert dollars to cents, and then because we're not using floats to track monetary currencies in this, floats have different effects on different machines and different languages. Floats round weirdly, and so we want exact values, so we are just converting to cents, and just adding summing cents and converting back to dollars from there rather than having any rounding take place. So yeah, and then we just break out of that. So also to account for just the whole integer values being given as alphabeticals, we try to do this cost of good and just do an initial conversion right away. And if we can't do that because we are given a whole just 8 alphabeticals, then we raise this error here. So that accounts for detecting the cost of the good. Now we have another loop here where we detect the size, and that's where we check to make sure that it's in that tuple from above. We take a date created, which generates a date created function. So this date created function where we generate a date, we provide the user with the option to select the current date, or we need to then we need to implement a way for the user to add in a custom date for maybe it was a purchase in the past. And so we need to add that in here on this line and replace this pass statement with that implementation. So we will get there probably tomorrow. I think that's what we'll work on tomorrow. We're about to wrap up probably for today soon anyway, so we probably don't have time for today, but tomorrow we will definitely implement that. That sounds like a good plan. Next thing we added, right? So then what we did was we started actually getting to that quantity aspect that we implemented today. So we removed the quantity from the individual item aspect and made it more of a outside the parentheses multiplication happening going on. So we just have placeholders for the range values of quantity if quantity is greater than 1. Right, so if it's greater than 1, we generate placeholders to generate an item number, take that new item number, put it on our item, and then generate the item inside this place, and then append it, and then loop into the next place and repeat. And so that successfully, what it does is it creates duplicates like you can see here with new incrementing item numbers every single time. So what I'll do is I'll run this program one more time. We'll say yes, enter. We'll go into the inventory tab. We will add an item here. We will say item name is item 2 to just be a specific test. And we'll say the cost is 500. We'll say the size is a large. And we'll use today's date. If we press 2, we would just pass. Remember, we don't have that implemented yet. As we said earlier, we need to do that tomorrow. But we'll just press 1 to use today's date. And we'll say quantity. We'll generate 20 of these guys. And boom, we go main menu. We press exit and press 1 to exit out. When we go to our items tab, as you can see, item numbers 11 through 30 are all the duplicated items created. So we successfully added in a bulk add feature for the same item on that current date created. So just another way to make it easier on the user to load in these items in mass. So yeah, so cool. We're adding on there feature by feature, guys, little by little. So stay tuned if this is exciting and something you're interested in. And yeah. All right. What should we work on next here that's quick? Let's go ahead and push this. Removed quantity attribute on the local level. Added it's too long of a commit line. So adjusted fixed, no, adjusted item quantity added shifted to bulk add method. Shifted to a bulk quantity add method. So we'll say quote bulk quantity add method. Cool. Yes, item, no, so item name isn't a key in the dictionary. Oh, let's get caught up on the chat. Jeremy says, yeah, is the item name a key in the dict? I forgot. No, item name is just an attribute associated with these individual objects, whereas the only dictionary that we're using is just the data structure to house these specific objects and the classification of them thereof. So we have items, for sale items, and sold items. Items become for sold items, which become sold items. And so they're housed according to these different keys in this dictionary above. So yeah, it's really cool. Okay. So I was thinking also, guys, is we might want to think about how we are going to actually, now might be getting ahead of ourselves, but down the road we might want to actually add a way for the business to add expenses and track expenses as well. So we might have to make more objects, another class file for expenses and tracking those. And honestly, that's going to be a deep dive. We're going to have to figure out how we're going to organize those, because you can have expenses of many different types. So we'll have to just play that by ear. Jeremy says, a dict with keys of items could be used to store the quantity of items since it won't allow duplicates. So a dict. So a dictionary with keys of items could be used to store the quantities of items since it won't allow duplicates. It does allow duplicates. We've added in the duplicate feature here, so everything's working appropriately, Jeremy. So I'm not sure what you're referring to really, but everything works as it's supposed to right now. Avinash says, have you been reading Fluent Python outside of the live streams? No, I haven't. I've been saving it for just the streams, which is kind of annoying because I do want to read it, but I'm currently, I don't know, I can only take on so many projects. I feel like I don't want to be that guy that starts a bunch of stuff and hops around. I want to, start something and I want to finish it. I feel like that also helps people to stick to their own projects as well, rather than just floating around. But, floating around can be beneficial to some people, so. But haven't you been reading Avinash? I think I remember you telling me that you were reading Fluent Python. I see what you mean, huh? On chapter 4 on Fluent Python, I've been learning a lot. Oh, you're making me jealous. I'm not gonna lie. I wish I was working on it. I have it right here. Gosh dang it! It's just calling my name, taunting me, ready to be opened and learned. But I currently doing the DSA book, and that one is that one is a doozy. That's for sure. But yeah. All right, you guys. Let's see. We need to. What do we need to do? If we press 1, press inventory. We have add item. We don't have remove item yet. We need this. We need the find feature, and we need the view feature. We need. I don't really want to make these right now. I'm kind of being lazy. Let me go ahead and close up some of these functions so it's easier to read the program. Okay. And then we'll run these, open these two. Okay, so we need to establish the transactions menu. We need to add in all these other features as well. We got a lot to do, everybody. So buckle down. Jeremy says, because we removed quantity altogether, I'm thinking about if you want the functionality to be able to see the total count of type of item. Say for dresses, how many total dresses are in inventory. Yeah, so you would have to filter by name then, unfortunately. Um, is the only way I could think of it. Unless we give it some sort of tag that it was grouped together, right? That they're all the same item in like down to a breakdown, right? African boy, I appreciate you joining us. I appreciate you. Thank you for leaving a message. Um, Jessen, I appreciate you coming in and leaving a message too. Thank you. He says one way to save a bunch of space is to abstract and split classes into different files. It's a great way to organize. Yeah, we have our class file right here that we are pulling all of our data from current or our object creation from currently. So we're importing that into our current file. Yeah, so thanks for the suggestion. Appreciate you. Yeah, so what Jeremy is saying is there's actually no way to technically tell that all of these are the same item, right? Like they they could be different items. There's no definitive proof besides just the name that they're the same. So, is there a way that we can give them some sort of tag to show that they are all grouped in the same category or item? I'm not sure. I mean, what do you think? Like, you would have to obviously give it another attribute saying that it's a dupe, right? Like, dupe is true, which means that there's multiple. Fluent Python only has worked examples, so it'll be a lot easier to go through than the DSA book. Been placing all the worked examples in a Google Colab and adding comments as my way of taking notes. That's great. Exactly. That's exactly. Check out from collections import counter. Looks like you might be trying to import the counter class from collections module in Python. However, there's a small mistake. Whatever. Counter is a subclass of dict that used for counting hashable objects such as string, lists, or tuples. Here's an example of how to use it from collections import counter. So it just counts the items in an element and it will return, oh, a dictionary. Oh, that's interesting. Thank you, Jeremy. Okay, so the collections module has a counter class that will, when created and called upon an iterable type, will take a count of all of the items under with the same key value, with the same name, and count them. That's a good idea. That is a good idea. Okay, so we could essentially call a counter for when we're filtering these items. Dig says, is this a project you're working on your own or an example from the book? This is a project completely on my own. I've completely started from zero, scratch. This has all been out of my own head using, your guys' suggestions and references and everything. So, yeah, this is just completely from scratch that we're starting this a whole project, a whole application here. Appreciate you coming in and digging and leaving a message. Thanks so much for joining me this evening. Use collections, I definitely recommend. Yes, that sounds like something we're going to have to do. So, Jeremy, how do you think we should implement that exactly? So, it would have to be called to like filter, right? When we're filtering, obviously, when we're filtering for display or for the find and edit, we could call the collections and use that in certain circumstances, right? I think would be the best way to go about it. But oop, my stream is lagging here. Apologies. Dropping frames every once in a while for some reason. It's really annoying. I'm gonna have to get an Ethernet cord and plug it into my dock here. But just a quick introduction to those that are new here. Hello, my name is Michael. I appreciate you joining me. I am a formulation chemist. I graduated college back in 2021 with a degree, a Bachelor of Science in Human Biology, and a minor in Chemistry. I specialize in the chemistry side of human biology and physiology. I currently work as a formulation chemist for a large biotech company where I make biological controls used to diagnose patients for in clinical settings. This is used for patient testing and for patient sampling and things like that. I make these these products in large bulks that get from pilot all the way from small to large scale, and I'm just found some various moments in my life where in my daily career at work where I have to either hand formulate various theorem matrices. I have to manage a lot of inventory personally, and so I was just thinking of ways, how could I further automate or improve my workflow and my life? Well, maybe coding and programming could serve me some purpose. So I quickly learned, or not quickly, over the past 6 months, I've been teaching myself on and off various Python and coding principles. Currently, we are reading data structures and algorithms in Python, and we start the streams off with the first half with learning DSA, and then in the second half of the stream, we work on and actually implement all that learning into real practice projects and into something that would be actually tangible and usable in the real world. So right now, we're working on a small business manager application where it will take in and manage inventory, process those inventories into sales, manage and track those sales, and provide reports on those sales. And then maybe even track expenses eventually, create expense reports, and hopefully maybe generate tax documents with all of that information together, such as like income statements, cost statements, all that kind of stuff. So we could just make this a conglomerate, software for small businesses or maybe even medium businesses. Jeremy says you can expand this forever, like getting the average price of the type of item. Then you could use that to set a sale price that stays at, say, 20%. Ah, interesting. You can expand this forever, like getting the average price of the item, of the type of item. Then you could use that to set a sale price that stays at, say, 20%. Ah. Well, my stream is, I'm really dropping a lot of frames, guys, and usually what this happens is I need to restart my computer. But that being said, I think I'm going to end the stream here. We've been streaming for over almost 2.5 hours this evening. I do work a 9 to 5. Like I said, I stream after work. So I put in, 9 to, or not even 9, I put in, 12-hour days every day, Monday through Friday. And then I stream about 4 or 5 hours as well on the weekends. So I'm really committed to learning this. So please follow along if you are also in a similar situation, whether you're beginner or advanced, just wanting a place to come together and learn and take the pressure off and the stress off and the competitiveness off of learning programming in the current day. I think it's critical to maintaining sanity. Justin says, "What resources do you use to learn? I'm studying software engineering, but I'm always bad with learning, and I'm even just sitting down with coding. Any advice?" Yeah, Justin, no worries. Feel free to join the Discord link below. That's just a collection of all of the resources I'm learning. I provide all the PDFs for the books I've read. Um, just quickly, you guys, before I sign off for today, I read all of part 1 of Python Crash Course live on stream here, just like I'm doing with the data structures and algorithms in Python. I read all of this live on stream, went through it, broke it down when I was learning it. I did all of the practice problems in the text, and then all the try it yourself problems. And then on my channel, I'm currently going back through and posting solution videos to those practice problems to further give myself practice, and then also provide you guys with additional resources. We are going to eventually get into Fluent Python, as we've been talking about on the channel. We will dive into this one, and then we will dive into Python machine learning after that. We have a lot of books to go here, but currently we are reading the PDF version of the data structures and algorithms in Python. We are at the end of chapter 3. We're working on these reinforcement problems, going over big O notation and time complexity in functions. And it started off a little rough, not going to lie. We were struggling, but honestly, we've been able to work through almost 20 of these problems and feel pretty confident in getting to the answers and working with, a little bit of AI when we're getting there. But some of them we've been able to just breeze by and solve on our own. And so I'm feeling really good and with the progress that we're making. So, this is just a testament to saying that, all this time that we're putting in really works. So, and it's proving that it's working for at least this setting in this example. So, if you want to put yourself to the test and, you can do hard things as well. You just got to put the time and dedicate yourself into it. So join the Discord. get access to all these resources down below. Keep watching the stream. I interact with you guys daily to talk about coding, practice. It's really my number one passion right now. I have a lot of fun doing this. Seeing the channel grow really is motivating me. Honestly, I can't stop talking about telling people about it. I'm streaming after work and people are watching me. It's really awesome. I can't believe it, and it's great that we're making a lot of friends here, a lot of connections in the Discord. We have like Jeremy is in college. We have a lot of people in still in school that are graduating. So we're gonna have a community of programmers here that are gonna be in the field. So the connections are gonna be valuable as well in the community that we're creating. But yeah, thanks so much for watching, guys, today. I'll be back tomorrow around 6:37 p.m. PST, like every day I do after work. And then on the weekends, I'll be streaming, 4 or 5, maybe 6, 7 hours if I have enough time and energy. But I usually like to relax a little bit on the weekends. But obviously, I do want to practice every day, keep going at this. It's the only way to really get this stuff super solid, and I want to know this stuff really well. I want to become a master at Python and be able to, to type out Python code like I'm speaking English. So that's my goal. We're making this project here live on the channel as well as reading, and I'll stop yapping here, guys. You have a great evening. I'll see you guys so much. Thank you. What's the book you recommend you start with? Definitely start with Python Crash Course if you're looking for something to start with. And then use that in tandem with CS50P, the Harvard CS50P Python course. It's a great course for getting the introduction, but sometimes can have a little bit of jargon, so that Python Crash Course book really helps to bring those topics to life and see you give you an example of how to use them and stuff. So thank you so much for following along to the channel, Justin. I appreciate you. I'll see the rest of you guys later. And honestly, thank you so much for the support. It's been overwhelming.